Now, let's connect the sensor to a DC supply. To do this, connect the brown wire to the positive and the blue wire to the return. Now I'm increasing the voltage to 24 volts. A quick test to detect the presence of my hand will show me if this sensor is working. To connect the sensor, take its black wire, connect it to EXT1, which corresponds to the topmost channel on this evaluation board. Let's test the sensor again. As demonstrated previously by the sensor itself, its LED turns on and off depending on the proximity to my hand. We also need to provide a ground return path to the COM pin. Let's connect that and retest the sensor. There we go. Now, as you can see, we have completed the entire path from the sensor to the input of the LED emulator on the Si838x all the way to the output LED on the 838x's evaluation board. So, big deal, right? Why could this be useful? One of the most useful applications that I can think of for a capacitive proximity sensor is to fill up bottles of beer. In this demo, we have two sensors. One will detect the presence of a bottle. We can see its LED turn on as I move a bottle in front of it. The other sensor will detect when a bottle is filled. Look in the background. We can see the voltage of the Si838x output change when the bottle is filled. One of the limitations of the capacitive sensor is it's limited to about 100 Hz bandwidth. That's fine for counting beer bottles going down a production line. However, another application for PLCs is servo motors. Servo motors have control signals from a PLC controller that can operate up to 2 megabits per second. This is significantly faster than the 100 Hz of a capacitive sensor. To quickly demonstrate the high-speed capability of the Si838x, we will use a 2 megabit square wave from a function generator and apply it to the same EXT1 channel that was used to count beer bottles. As you can see, the Si838x easily transmits the signal across the isolation barrier. Where's that beer?